Moksha, just wait for 1 minute and put out the apparatus for it.
Good evening, sir.
So what are we doing today?
Good evening, sir.
Good evening, sir.
Good evening. Good evening, everyone.
Good evening, sir.
Good evening, sir. Sir, can you once revise electricity, sir?
Pardon?
Can you once revise electricity, sir?
Electricity. When do you have exam for that?
Sir, tomorrow.
Tomorrow. So let's say today we had a plan to complete acid, bases, and salts. Right?
Let's do acid base.
Yeah.
Okay, sir.
Because today is chemistry class also, and we have half finished that chapter. We are just in between somewhere of that chapter. So let's continue with the same chapter. So this is acids. So in the last class, we had studied what are acids and the various definitions of acids. Like we had seen that acids are defined as the substances which give H plus ions, and bases are the substances which give hydroxide ions. Today we will see the types of acids. Also, we had seen a few questions, right? From this chapter, we had seen a few questions also. So here, today we'll consider the types of acids. So there are different types of acids depending on the different criteria that we use. For example, on the basis of their origin, from where they originate. So on the basis of origin, they are classified either as organic acids or inorganic acids. On the basis of their strength, we can classify the acids to be a weak acid or a strong acid. On the basis of their dilution, we can classify the acids to be a dilute acid or a concentrated acid. So what are organic acids? Ionija? Yes, Ionija, what are organic acids? Sudhanshu? Siddharth? Siddharth, what are organic acids?
Sir, organic acids are acids that are obtained from the nature.
That are obtained from
Nature.
nature. So organic acids are the acids which are obtained from living organisms. What is acids obtained from living organisms? They are called organic acids. So any examples of organic acids? Any example?
Sir, citric acid, tartaric acid,
Citric acid, tartaric acid, okay.
methanoic acid,
Citric acid, tartaric acid, methanoic acid, these are the examples of organic acids. And what are inorganic acids?
sir, which are not obtained, which are made in lab.
Yeah, so they can be made in the laboratory, they are not obtained from the living organism. So if, for example, we can say HCl,
Yes, sir.
H2SO4, these are inorganic acids. What about H2CO3? Is it organic or inorganic?
Inorganic.
Yeah, H2CO3 or carbonic acid is inorganic. Okay, then what are weak and strong acids? Aryan, which acids are weak acids?
Who, sir?
Which acids are weak acids?
Sir, weak acids means it has low H plus concentration, sir.
Weak acids are the acids which have less dissociation. Okay, they do not dissociate completely into their ions. So I'm writing here the weak acids. Weak acids are the acids that do not dissociate completely dissociate completely. They are called weak acids. Any examples of weak acids?
Acetic
HCl.
acid.
Which one?
Acetic acid.
Acetic acid. Any other?
Citric acid, then
Citric acid is the
lactic
same as
acid.
acetic acid. Sorry, not same. Acetic acid, citric acid, and
Lactic.
lactic acid. All these are weak acid. Okay. H2CO3 or carbonic acid, it is also a weak acid. They do not dissociate completely into their ions. Whereas strong acids are the acids which dissociate completely into their ions, almost completely into their ions. They are strong acids. So strong acids can be considered as HCl, H2SO4, nitric acid, then dilute and concentrated. What are dilute acids?
Sir, in dilute acid, the acid contains greater concentration of water.
Yeah, it has a high percentage of water, that is it is called as a dilute. And the concentrated acids, they are the acids which have less percentage of water in them. They are concentrated. Understood? So you can make any acid. You can make any acid to be concentrated or dilute. Any acid that you have taken, it can be made concentrated or it can be diluted. So how can we dilute acids? How can we dilute the acids? Let's see the method of dilution, how we dilute the acids.
Slowly adding water to it
Okay.
while it's mixing, while spinning.
Okay, so dilution, it is the process of adding water to acid. Okay. So you are adding, however, the definition says that dilution is the process of adding water to acid. It doesn't mean adding, it means increasing the amount of water in an acid. Okay, that we call as dilution process. So you have the process of dilution, like which substance is added in what? You add acid to water or you add water to acid?
Water, acid to water.
Acid to water, sir.
Acid to water. So how do we add acid to water? Can we directly add the acid in water?
No, sir.
So what is the process? How do we add it? How do we add acid to water?
Sir, we add it in a very little amount.
See, to add acid to water, when we add a small amount of acid in this water, we keep on stirring it constantly. So with constant stirring, the acid should be dissolved. Small amounts of acid added. Okay, so small amount of acid added in this water, and then it is constantly stirred to make it mix it well with water. Again, a small amount of acid is being added drop by drop, and it is stirred continuously, so that whatever heat is dissipated, whatever heat is produced during this process, that heat escapes out the solution, or that heat is absorbed by water slowly and slowly, and hence it will escape out also slowly. So there will not be much rise of temperature. Okay. What is expected when you add water to acid? Yes, what will happen if you add water to
A
acid?
lot of heat will be dissipated.
Yes, a lot of heat will be generated. So when we add acid to water, a lot of heat is generated. Right? So this is an exothermic process. Exothermic process means amount of heat is generated over here during the process of dilution of acids. Okay, so now after this we have, let's see what else is remaining in this chapter. This is your chapter. Yeah, the test for the acids. So how do we test acids and bases? Abhinav, how do we test the acids and bases? What are the different methods of testing?
Through litmus papers and olfactory indicators.
Litmus paper, olfactory indicator, and you also have some natural indicators.
Yes.
So what
Sir,
are the
turmeric.
natural? Yeah,
Sir, turmeric and
turmeric is a natural indicator.
flowers.
China rose is a natural indicator.
Red
name
cabbage.
red cabbage? Yes, red cabbage.
Sir, isn't litmus also a natural indicator?
Litmus is a natural indicator. Okay, where do we obtain litmus from? Very good. Where do we obtain litmus from?
Sir, lichens.
Lichens. Okay, lichens is the source of litmus paper. Litmus. So litmus is a chemical which is extracted from lichens. And what are lichens? What are lichens? Can anyone tell what are lichens?
Fungi.
No.
Fungi, algae,
They
mixture.
are an association of algae and fungi. So lichens is an association. It is an organism which is an association of algae and fungi. So algae and fungi live together. Which type of association is it?
Symbiotic.
Yeah, it is a symbiotic association. Okay, so in the symbiotic association, both the organisms are benefited. Whereas in the parasitic association, one of the organism is benefited and the other organism is not. So lichens is a symbiotic association between algae and fungi, from where we extract the which is the natural source for extracting understanding chemical properties of acids and bases. How do acids and bases react with metals? So let us see how do acids react with metals. So all the acids, they react with metals to liberate hydrogen gas. Right? Almost all the acids, they react with metals to liberate hydrogen gas. So what are the products found when an acid reacts with the metal? There, what are the products found when an acid reacts with the metal?
Sir, hydrogen gas and salt.
Hydrogen gas and salt. Yes, hydrogen gas and salt, they are produced. And how do we test the hydrogen gas?
The hydrogen gas burns with a pop sound when a flame is put near it.
Yeah. So when a burning candle or a flame is put near hydrogen gas burns with a popping sound. This is the test for the hydrogen gas. So whenever here is an activity shown between zinc granules and dilute sulfuric acid. So which gas is formed here? In this, which gas is formed? Hydrogen gas. Can you write down the reaction? Yes, and can you write down the reactions involved? Am I audible to everyone?
Yes, sir.
Yeah. So have you written the reaction involved here? It is the zinc granules reacting with sulfuric acid.
Zn plus H2SO
Zn plus H2.
gives
Yeah, Zn plus
H2.
Zn plus H2SO4. What do you get? ZnSO4 plus?
H2.
You get ZnSO4 plus H2. Now, the reaction that takes place can also be written as this one. So this one is a reaction of a base with metal. So do metals also give us hydrogen gas? Yes. Do metals also give do bases also give hydrogen gas when react with metals?
Yes, sir. Yes, sir.
Yes. So bases also give. So only some of the bases, not all the bases. A few bases give hydrogen gas with a certain metals. For example, sodium hydroxide when reacts with zinc, it gives us sodium zincate and hydrogen gas. Sodium zincate is a type of salt, is a salt. Then the reaction of metal carbonates and metal hydrogen carbonates with acids. So metal carbonates and metal hydrogen carbonates, they are supposed to be basic in nature. Okay. So metal carbonates when react with acids, they give salt plus carbon dioxide plus water. What will be formed? See, metal carbonates, if you perform the reaction of metal carbonates with acids. So, what is the expected product here? Since it is a carbonate, so it will give you carbon dioxide. It is metal, so it will give you a salt. Anything else that will be produced?
H2O.
H2O or H2? What should be produced here?
H2O.
Yeah, here you have the formation of water. So when metal carbonates treated with acids, they give carbon dioxide, salt, and water. Now see, there is a common question that generally heats up. Okay, the question is that if somewhere if you have acid fallen on someone's body, so by what substance will you treat it? Will you treat it with a metal carbonate or will you treat it with a base?
Base, no, sir.
Base? Why not metal carbonate? Just think of it. Ionija or Siddharth, can you answer? Siddharth, can you answer? Dhairya? Dhairya, are you there?
Yes, sir.
See, if you do not respond, I will quickly message in the group.
Yes, sir. I'm here, sir.
Yeah. So see, now see what happens. If you have acid with base, okay. If you are treating an acid with base, then also you are getting here salt plus water. Okay. If you are treating a metal carbonate also with an acid, then also you are getting carbon dioxide, salt, and water. Now, which one is a better thing? Is this one better or is the first one better? Now the answer is this is not better. This is avoided. Why it is avoided? Can anyone think of why we avoid this?
It's exotherm.
See, the chances are that if you have some acid bonds and if you add a base, so bases are also corrosive in nature. It's not that bases are not corrosive. Bases are also corrosive in nature. So if you have a again base falling on it, so still you will have corrosive action occurring. It will also cause burning sensation. Provided you are not going to control, you can't control it that yes, each molecule of the base is going to combine with the each molecule of the acid. So obviously your burning sensation will increase when you have the amount of base added on an acid burn. Another reason you can say that the amount of base required may not be calculated perfectly. So since or you just a simple answer would be that even the bases are also corrosive. So if we add bases on an acid burn, it may corrode it further. It may increase the burning sensation. Got it, everyone? Yes.
Yes, sir.
Yes.
So which one should we use? Metal carbonates. We should be using metal carbonates because here, first of all, the metal carbonates, they are not going to harm. They are not going to cause anything else over there. They are not going to corrode. Secondly, they are also going to perform the neutralization reaction. They are liberating carbon dioxide and water. Okay, so along with it, carbon dioxide is also formed. So water is also formed. So this metal carbonates should be used instead of using the bases. We should not wash acid bonds with bases. Got it? Acid bonds must be washed with metal carbonates or metal hydrogen carbonates. Even metal hydrogen carbonates can also be used. Okay. So see here, just have a look at the reaction occurring here. The reaction that's given here on the side. Here you have a test tube, and this test tube has sodium carbonate in it. And along with the sodium carbonate, you have added dilute hydrochloric acid here. You have a chisel funnel, and here you have a delivery tube which collects the gas passing from here, and the gas is passed into the calcium hydroxide solution. Okay. So can anyone tell me what is happening here in this complete process? What reaction is taking place? What is formed? Then what are we testing? Sudhanshu? Sudhanshu? Huria Ishaq?
Sir, CO2 plus CaOH.
CO2 plus.
Sir,
Okay,
no.
write down the complete
CA
reactions involved. Write down here the complete reaction involved. Write down the complete reaction involved. What are the products that we are getting?
Sir, SO3, SO3, SCO3. NaCO3 plus HCl gives NaCl plus H2O plus CO2.
Okay, all of you write down the reaction. All of you write down the reaction for this. All of you write down the reaction.
So we get NaCl, H2 and CO2, right?
Write down the complete reaction. Complete. What is the reactant? What is the product?
Sir, roads.
Which one?
Sir, test tube A. I wrote test tube A, sir.
Okay. So what are the reactions involved? Can you speak up the reaction?
Sir, NaCO3 plus HCl gives rise to NaCl plus H2O plus CO2.
Okay, so just one. Okay. Now speak up your reaction.
NaCO3
No, it's not NaCO3. Check it again.
NaHCO3.
No. It is sodium carbonate. So it is Na2CO3. The formula of sodium carbonate is Na2CO3. Okay. Then what is added here?
HCl, sir, hydrochloric acid.
Okay, HCl or hydrochloric acid. So what is the product form?
Sodium chloride
Yeah, sodium chloride,
plus
NaCl plus
OH
plus
plus OH
OH,
H2O
H2O and
CO2.
CO2. Okay. So what are the products that will be at different places? Where will you get the carbon dioxide gas? Where are we going to get the carbon dioxide gas?
Test tube
Hmm. Where? Okay. See, the carbon dioxide gas produced in this reaction, produced during this reaction, passes through the delivery tube into the second test tube. Okay. Now, what is the reaction occurring in the second test tube and what is the reactant over there? Write down the reaction in the test tube. Yes, which is the reaction occurring in the test tube?
sir, calcium hydroxide.
Okay, what common name for calcium hydroxide? Or
Sir,
what will be
CaOH.
CaOH? No,
Plague line.
Slag lime.
slag lime. And what is the formula?
Sir, CaOH plus
PO is taken twice.
CaOH twice. Right? Do you remember the formula? So calcium hydroxide is CaOH whole twice. This is calcium hydroxide. Okay. When this calcium hydroxide combines with carbon dioxide, so what are the products formed? Yes, come on, answer this to answer this. You have answered the first one. So here you will have calcium oxide plus carbon dioxide. So what do you get as the product? Yeah,
Calcium carbonate plus H2O.
calcium carbonate plus H2O. Okay. So what changes will be observed here in this reaction? What changes will be observed? See, the changes observed here in when calcium hydroxide combines with carbon dioxide. See, this is lime water. Calcium hydroxide, this is lime water. And when you pass carbon dioxide through lime water, so what happens? Yes, what change? You will have milky color. There will be an appearance of milky color due to the formation of calcium, insoluble calcium carbonate. The calcium carbonate will be insoluble, so therefore you will have the formation of appearance of milky color in calcium hydroxide, or you can say the lime water turns milky because earlier colorless.
Sir, did you call me, sir?
Yes.
Sir, did you call me, sir?
Repeat, what do you say?
Sir, did you call me, sir? I just went out from.
No, just now I didn't call you. I was just talking of this, that calcium carbonate formed here. It gives this solution a milky color. So in this complete process, you have formation of here calcium carbonate, which turns milky. It shows the formation of carbon dioxide gas during this reaction. So which reaction we were doing? We were doing metal carbonate. We are doing the reaction of metal carbonate with acids. Metal carbonate with acid will give salt plus carbon dioxide plus water. Okay, got it now? So today we have completed this. In the same way, you have the reaction of metal hydrogen carbonates also with acids. So in the same way, metal hydrogen carbonates also react with acids to produce salt, carbon dioxide and water. Okay. The products are the same for both. Okay. So bye all of you. See you again in next class.
Bye, sir. Thank you, sir.